Alright, time for another DraftPhysics.com, DebatePhysics.com, also video presentation. So, the 21st video, responding to Professor Dave's conventional physics description of reality that I say has very little to do with getting any of the elemental functions right. So, yeah, some of the you can sometimes believe fish can talk, and you can still, you can still draw a picture of the ocean and it all seems rational. But it's just not the truth. So you can get some stuff wrong and you can still figure out how to put a worm on a hook. But they really do have it elementally wrong. And it's easy to figure out that what they're saying is in contradiction to actual evidence. So their physics says it takes 25 times the fuel to spin something 5 times as fast, and that something going 5 times as fast has 25 times the capacity to do work. And it's clearly not true. All right, so they'll do some experiments moving something twice as fast now and then and get kind of mushy, fudgy results because they use springs and different devices to collect the energy, and they don't always collect it evenly or linearly. And so they can get a close to the right answer, but still not the right answer, but some indication that it might be true because they're really just collecting errors in the way they've done the experiment. But they'll never do the dramatic cases. And there's just simple arguments. 16-pound bowling ball going 8 miles an hour going one way, 8-pound ball going 16 miles an hour going the other way. Make a little steel U and have the two balls hit it at the same time. The 8-pound ball is supposed to have twice as much energy, but the steel isn't going anywhere because the two have the same momentum, and momentum is all there really is. And momentum exists in all its forms. Heat is momentum. Electricity is momentum. Everything is momentum. Everything we call movement or motion contains momentum. There's no nothings in the universe. There's only somethings. And they interact and they exchange their momentum. And that's really the truth. That's all that's going on. And they've created a whole mushy, wooey, Smurf-filled SpongeBob cartooniverse that really doesn't have anything to do with the reality. And I'm just making those arguments, and I think I'm making them decisively. And the funny part is, clearly the argument that there's no evidence demonstrating their silly statements is undeniably true. They never even measured 4 pounds dropped 1 foot and 1 pound dropped 4 feet to see that those are not equal. They claim they are, but they're clearly not. And a lever proves they're not. So it's, you can go through all the experiments, ballistic pendulums, all kinds of examples where they can't collect this kinetic energy. Momentum landed man on the moon, not kinetic energy. Thrust is momentum. It's not kinetic energy. You can go on and on and on. And yet, I make these videos for years, making these arguments that are decisive and completely incontrovertible. They will not show any experimental evidence demonstrating the collection of this quadratic increase in energy, because it doesn't happen. There is no real V squared function. Okay, it doesn't happen. All right. And there's nothing I can do about that, right? Because, I can only make reasonable arguments and then just sit here and ponder the fact that there aren't reasonable people to argue with. That there's just a bunch of religious kooks defending a religion. And they don't have any evidence. They won't concede they don't have any evidence. And they'll just say, you fucking sinner. And just waste time saying, you fucking sinner. You heathen. You heretic. Just nonsense. And they'll slander Isaac Newton in the process. So anyway, that's where we are. So we're on electricity, really interesting subject. And it shows lots of these profoundly important things to understand. So Yeah, maybe I'll draw a little again. This is a little bit redundant, connected to the last video, but I will just reiterate a point because it relates to heat and resistance. So the title of this video is Electrical Potential, Current, and Resistance. It's really going to be about electricity, the flow of electricity. And the simple argument I've made is for electricity to flow, what it needs to do is the energy has to stay linear in a wire. So you want the electrons to very smoothly in all the same direction push on each other. You don't want electrons that are pushing this way and pushing that way. That just gets in the way. That's a waste of the energy. So you basically want to just contain all the movement in this straight a line to get the energy through the wire, okay, to the other side. And resistance is basically when something does go in some other direction. So as I pointed out, the lower the pressure of the electricity, the more likely it is to go in other directions because of all this jittering motion in the wire. And the hotter the wire gets, the more resistance there is to that forward motion, because you can sort of understand if it's jiggling this way, it's going to steal energy from this direction and make it go this direction. So the more these electrons and protons are jiggling, the more the atoms are jiggling, the more the electricity is going to have a hard time going straight. All right, it's just going to get in the way. And and so you can also understand it as the phenomenon of magnetism is, in a sense, you need the the resistance and the motion of more and more atoms is what sort of creates the idea of having more and more magnetism. So that's where you want a high amperage and a low voltage, because you want to affect as many atoms as possible to create as many dipoles as possible. So you're basically just saying, look, I can make an atom and I can make a bunch of atoms that are not polarized, or I can polarize them all in the same direction. And so what the electricity is basically doing is polarizing the atoms in the same direction as the motion of the electrons. And you could just sort of understand that, yeah, I need all the atoms. The more atoms I involve that I polarize in the right direction, the stronger the magnetic field becomes. And so if I just have a very straight, high voltage that just goes this way and doesn't involve a whole bunch of atoms, then I'm not going to create any magnetism. All right. So that's a sort of a... So it can all be deduced, all right? The available evidence exists, and they could do so much more to prove things deeper and more thoroughly, but they don't bother doing any of the elemental experiments. They don't bother taking a 5 mass going 10 and a 10 mass going 5 and tying a rope between them and seeing for themselves that the 5 mass going 10 does not have any more capacity to do work. All right, they won't bother. They'll spend billions on nonsense looking for wooicles, but they won't spend $25 doing the important experiments. All right, so that's probably enough of a premise. And leave us play the video. Yeah. See if I can do that without making a mess somewhere.
We now know about the electric force and the electric fields that propagate this force.
So there's no point in talking about electric fields that they don't define. So my simple argument is the field is made out of real things, something, not a bent space, not a ambiguous field. It's real momentum carrying substance, and that's what's making momentum. That's what's giving electrons and protons momentum. Is this stuff has to be collected by them, just like we collect gravity. They collect it, and it changes them physically, and that's why they keep moving.
So how is this useful to humans?
So that's the silliest question ever, and that's not physics, right? Physics isn't asking the question, how is this useful to humans? Physics asks the question, how does it happen? What makes it happen? What's the function? Show me the mechanics. That's physics.
To answer this, we must understand that just as there is gravitational potential energy,
So there's no gravitational potential energy. There's rivers, and you can put a boat in them, and the boat will flow, collect energy from the river. There's a sail, and you can collect energy in an object by the wind pushing on the sail, and the force goes into the mass, and the mass collects it and moves. So this idea of potential energy, when it's not true storage, you're sticking something in a flow. You don't call that potential. If I stick something, by a fire, and the radiant energy pushes it, okay, it didn't have any potential energy. It's being pushed. Okay, if I put something, just sit something on the table and I shoot a fire hose at it, you don't say the object has the potential energy. It's just ridiculous. So all these things move because some force acts on them, as Newton stated in the first, second, and third law. You need you need the actor, okay? And matter can carry force, and matter can exchange force, but it's force ultimately that's pushing and creating pressure. It's a push-averse. I mean, again, just do you really think that 1,000 years from now, they're not going to be saying it's a push-averse? Do you think there's any hope for the idea that the elemental function is some sort of magical come-to-me pull thing? There's no pull thing. There's just push. It's the only elemental function that can exist, is you have to bang into something to interact with it. Oh, Jesus.
by virtue of an object's position in a gravitational field.
Right, so it's its position. It has nothing to do with it having anything. It doesn't have anything until you allow it to collect. So again, the water wheel doesn't have potential energy. It steals energy from the stream. The stream has less momentum after the wheel turns than before the wheel turned. Fact. Because it gave the momentum to the wheel. So you follow the force. You follow where it goes. It's a real thing, motion. And it's exchanged. It is not created.
There is also
it's like money. You can't, let's just say there was a certain amount of money in the world. Now, technically, it's pretty close to that reality. There's a certain amount related to population increase and this and that and that. And it's pretty close to being not horrendously overprinted. Now, the last 40 years, they have, changed the slope a little. But the idea is there's a certain amount of currency. And frankly, you just follow where it goes. Something can't have it unless it got it from something.
Electrical potential energy by virtue of an object's position in an electric field.
So the electric field really just has to do with what's being radiated by electrons and protons and whether you're an electron or you're a proton in that field. And it matters on which one you are.
And charged particles can flow.
So we know it's just about electrons. So there's no point in saying charged particles flowing because the protons don't do any flowing. It's just about electrons. So they should just keep the subject to electrons because that's all it is. It just has a little ease there. It's nothing about charged particles. It's about electrons. Electrons, electrons, electrons are electricity. The fact that it says electricity kind of has that idea of electron in it. This is just about electrons. And protons only show up indirectly when you take away enough electrons. The protons are now visible, but they don't do any moving.
And generate current, just like water in a river can flow and generate its own kind of current.
So again, it doesn't generate it. It had to get it. It's taking it from gravity. Gravity is pushing it down. Fact. Okay, and the ground, because it's sloped, it's giving the water the opportunity to fall further down. But it's still clearly stealing some of its energy, and that's why the mountains erode, is because the water bangs into it.
Oppositely charged particles, because of their charge, have the potential to accelerate towards each other, just like an object on the edge of a cliff has the potential to accelerate towards the Earth.
Right, it's the same inverse square law. It's the same law that photons leave the sun at. So it's all over the place, and it just really has to do with the idea of spherical symmetry. So it's leaving perpendicular to a spherical source those rays, okay, guarantee an inverse square relationship between distance, because the force, the stuff you're ejecting, the cannonballs, the bullets, doesn't matter, is spreading in 2 dimensions. That's the square part.
Because of its mass. And in each case, it is the field that does the work to produce the acceleration.
So again, he's conceding there's a field. Now, they don't believe that gravity is caused by anything real or like a field. It's a bent geodesic. It doesn't have any energy, where we know the field around electrons and protons clearly does. So this is the bullshit of this crap, okay, is that it's real radiant energy, real force, real stuff traveling between things, and it all moves the speed of light. So gravity moves the speed of light, light moves the speed of light, electricity, all these things are all somewhere related to this constant speed of this elemental motion in the universe. The matter has no innate motion. It has to have force interact with it and stick to it for it to move. Fact. And if it moves into a field of force, like electrons and protons do, they'll be dragged, okay, back to a halt by the fact that they're going to incur more force. So electrons and protons can't fly through space and hit the Earth. Can't do it. The only way the electrons or protons get from the sun to the Earth is in a plasma. They can't get here on their own.
As charged particles move within an electric field, their electrical potential energy changes.
So again, this potential energy thing is just such a dodge. They don't have any of that. None of this nonsense is true. And clearly, as they move through the field, it gets stronger and stronger. So as they get closer and closer, the strength of the gravity gets stronger and stronger. So it's nothing like gravity, because when we fall 100 meters, it's all the same force. When a proton or electron is moving towards each other, the change in the force is radically and intensely different. So it's getting stronger and stronger the closer they get to the surface. And we can only see that if we drop things hundreds of miles. Then we could see that it starts off very slowly and it starts gaining more and more. So when it gets, 1 meter per second, when it starts, and then it's 2 meters and 3 meters, and then not until it gets very close to the Earth does it start going 9.8 meters per second. So it's really wrong to imply that the field is constant, because it isn't.
For a uniform field, the magnitude of this change is equal to the opposite of the object's charge times the electric field strength.
So all he showed was a uniform field in the sense he took 2 flat surfaces, which essentially is an infinite plane. So that's like taking a bunch of LEDs, you could argue, and having 2 flat planes, and you could argue that there's no round surface now, so there's no inverse square law. So for a little period the force will always be the same no matter how close or far away I get, because as long as the plane of LEDs is much bigger than this target, it'll essentially be an infinite plane. And so there'll always be the same amount of photons that are going to hit the object. But, that's more to do with static charges than electrical transmissions. Potential, current, and resistance really isn't, capacitors alone. It's all the other circuitry.
Strength times its displacement from the reference point in the direction of the field. This leads.
So you get rid of the inverse square when you create semi-infinite planes. So when you create a flat surface instead of spherical surfaces, you have a different rule.
Leads to the concept of potential difference, which is the difference in electric potential between 2 points in an electric field.
So you're just talking about the pressure, and all this pressure is all about electrons and their conditions. So an electron all by itself doesn't have any pressure. What it needs to do is be next to other electrons, and then you can measure the pressure between the electrons. But if there's no other electron, then there's no pressure that you can see or discern. There needs to be other charged elements for the pressure to exist.
Expressed as the change in electrical potential energy over electrical charge. The SI unit for potential difference is the volt, which...
Right, so you're just talking, again, you could just equate this to the same as the momentum argument, in the sense that you have a mass and a velocity, and to decide what your momentum is, or your watts, power, how much momentum is flowing, you just have to do the same thing. You just multiply the mass, that is the volume of electrons being transferred, and then how fast the electrons are actually moving as they interact with each other. So the voltage could be clearly understood as just a velocity, and the amperage could be just understood as mass, how many. So it's just how many and what's the average speed. Now they do a silly thing where they calculate the average speed of the electrons in a wire by just saying how much is all the electrons. If every single electron was moving, how fast would they be going? If I spread the potential over every single atom in the wire. And clearly that's not going to be the real velocity, because a much smaller percentage of the atoms are actually involved in moving the electricity.
Which is equivalent to 1 joule per coulomb. This means that as a 1 coulomb charge moves through a potential difference of 1 volt, it gains 1 joule of energy. The potential difference for the 2 terminals of a common battery is anywhere from about 1.5 volts for small batteries.
So this isn't all that interesting, in the sense it's really not telling you why. Why is it 1.5? Why is that the standard? And it is a standard. And the 12-volt battery is just made of a bunch of 1.5s. I mean, that's the catch. So the 1.5 part is the part that's a standard. Now, they could explain that, but they don't.
To around 12 for a car battery. Batteries do work to move charges. So volts
So even that is kind of archaic, right? Because we know that a lot of things run on higher voltages than that now, like computer batteries and laptop batteries, that kind of thing. So, it's pretty common to have something running in the 20s.
Are not a measure of energy. They are a measure of change in energy per unit charge. As charge flows...
So again, more uninteresting statements or weird descriptions. The charge flow produces usable energy. What is that? Any flow, any movement is usable. It just depends on how much work you want to do to use it. But it's all usable. I mean, the sunlight missing the earth is usable. We just stick a mirror out in space and reflect it towards the earth. There, it's usable. So it's just silly to say there's such a thing as usable and unusable motion. It's all usable. Some of it's easy to use and some of it's hard to use.
It produces usable energy, like the way that flowing water can push a water wheel as it moves past.
So that's a pretty weird example, just because obviously they're not getting much out of that water to steal such a tiny, narrow little thread of it. You'd think they would want to channel it and, get as much of the force of the water to hit the paddles as possible.
In this way, we can discuss electric current and our ability to manipulate.
So this is the other part that's just silly. They have current and voltage moving in different directions. Clearly, just idiotic and silly. So, I mean, these are the kind of things they do in physics where you just say, why are you doing that? You know better. You know the current is going in the same direction as the voltage, all right? There's no way you could separate the mass of the electrons from the voltage or the speed of the electrons. You can't separate those events. They have to be going in the same direction. So this is just an artifact of the wrong assignment of plus and minus, and it's just it's ugly. It's ugly, it's so wrong.
This current is responsible for our mastery of electrical power.
So another joke, almost a joke, right? Clearly we're not mastering anything all that. It's like saying our mastery of water because we built Niagara Falls. So, come on.
A current exists whenever there is a net movement of electric charge through a medium. This can be defined as the total charge passing through a given area divided.
So again, he has the voltage going one way, the current going the other way. Just really stupid.
By the time interval.
So he really hasn't gotten to resistance at all. So let's see if he's going to talk about resistance. It doesn't look like he's going to say much about it, but resistance is a huge factor. So anything that causes any of the energy to change its direction from a straight line is essentially going to degrade, how much flow. So that's like eddies in the stream. They're counterproductive. They're stealing energy, kind of a thing. And they're wasting it. So that's the story, is that as say if you have impurities, the impurities create heat. The heat then makes it even worse in terms of now you have even more obstacles to keeping the energy moving the direction you want it to go.
The SI unit for current is the ampere, which is equal to 1 coulomb of charge passing a particular cross-sectional area per.
So this would all be so much better if they just turned it all into some one common unit of the weight of a toadstool or something. Just give it all in grams or something, because it's all just momentum. It's all just a pressure. So let's put it all in one kind of unit, and then just everything is in that unit instead of this crap.
Second, the direction of the current is always opposite the movement of negative charges. But a current.
So it's just idiotic, right? There's no possible way the current is in the opposite direction. It never does any of that. It doesn't happen. It's just really silly.
It can be generated by particles of either charge.
So we know that particles of either charge don't have anything to do with it. There's no proton electricity. It's all electron electricity. It's all about the movement of electrons. You can't move the protons. They're stuck in nucleuses. It just doesn't frickin' happen.
Most materials that are conductors of electricity are metals that allow for the free movement of electrons.
So this isn't true either. This isn't about any free movement, okay? The fact is that all the metals are crystals. And crystals line up all the atoms, and so all the electrons are on layers, essentially. So you can move the electrons really easy because they're all in layers with each other. They're all aligned. So that's why crystals are really good for creating polarity in the movement of charges. So it's really about the fact that metals are crystals, not about some notion that there's a bunch of free electrons. It's not really anything. There's there's no real such thing as a free electron. They can just be bound loosely. So like something in a weak orbit around, the further away you go, the weaker and weaker the orbit gets, and the easier it would be to take a little bit of energy and knock it out of the orbit. So clearly electrons far away from a nucleus aren't bound by a very strong force, and they're pretty easy to kick from one atom to another atom.
From atom to atom, or electrolytic solutions with charged ions in solution. The ability of a material to oppose the motion of charge.
So the ions are just switching from positive to negative ions, that is, atoms with too many, atoms with too few. And so you're saying atoms with low electron pressure, atoms with high electron pressure.
Is called resistance, which will be unique to a substance and vary by the dimensions of the material.
So whatever that means. So most of that just has to do with the resistance, has to do with common, resistance with impurities, and again temperature. So that's why if you can supercool, you're basically taking all the jitter out of the material, and therefore the electricity can flow without being distracted, sending energy in the wrong way. I don't know if there's I mean, clearly if you have a pool ball and you flew it straight, and then you said you had little tiny balls that you were throwing against the motion of the pool ball, you could understand that it could get bent and wobbled and screwed up, and that if you could go fast enough and get through that field without hitting too many of those little ones, then your energy will stay in the direction you were going.
This is the ratio of potential difference to current, measured in ohms, which are represented by the Greek letter omega.
So this is just a way of saying how much energy did you use. So the resistance is kind of a cheat to say resistance equals the amperage divided into the voltage, because obviously it's completely dependent on what you're actually doing with the electricity.
These are equal to 1 volt per ampere. Electric power, which is the rate at which charge carriers convert electrical potential energy to other forms of energy.
Right, so this is just the momentum, really. You just, this is, it's a P for power, but it's really just the same thing as momentum. And so this is just the simple equation of multiplying mass times velocity.
Is given by current.
No squared, notice. So in electricity, somehow the kinetic energy theory completely falls apart and disappears altogether. So here in the movement of electrons in a wire, somehow the velocity isn't squared. It's not more important. It's not twice or quadratically more important in terms of creating energy. And why would that be? Yeah, there's no good reason why there would be a difference. Indicating that electricity works really well. We got it pretty well figured out in terms of doing our math with it. And clearly there's no quadratic increase based on voltage.
Times potential difference, which is measured in watts, or joules per second. An incredible amount of technology,
which is joules, but whatever,
has been developed to utilize all these phenomena.
It all can be just converted again into a tonnage, an amount. You could just say it's this much pressure, but that's all that really happens in the universe in terms of interactions, is the meeting of two pressure differences.
In the form of circuitry, particularly in computing, which becomes more sophisticated every year. But
yes, and that's more electronics than electricity, but whatever.
In-depth analysis of circuits will have to wait for an engineering course sometime in the future. For now, let's quickly list a summary of the new units we have.
Yeah, so that's it. That's all he's going to give us. But anyway, so there's no real explanation of the key factor that resistance plays, okay, in essentially taking the energy out of the river, and how that resistance increases depending, say, if I put a wire in a magnetic field, I'm going to increase the resistance from the flow of the electricity because I have some other force that's, causing there to be a synthetic heat. In a sense, I'm just going to keep sticking with the argument that heat is when the energy, the motion, the electron pressure flows in all directions, and electricity is when it's going in one direction. Same difference though, same thing. Whether you're moving the atom or you're moving just the electron, it still requires you to move the electrons, push the electrons into each other. So essentially it's still an electrical function. When you bang into a brick wall, it's an electrical event that's really taking place. And the other surface is basically saying it has way too much electrical potential to allow you to push those electrons.
Just defined, as they can get a little confusing. With all of that in order, let's check comprehension.
So there's very little confusion. You just think that volts times mass, so speed times mass equals the power, and the tapping event is the resistance. So either impurities or heat or you pulling energy out is going to be resistance. All right. So I think that's enough of a video and such. I'll pause and see if I want to throw anything else in here. Yeah, I guess we'll conclude there. The next video is on magnetism, and it really does need to be, although it's the same charge as creating dipoles, and dipoles collectively create magnetism, so the two subjects are really related. But the fact is the pattern being created in space that moves from the magnetic object is different, and there's real and kind of complicated distinctions to be made between electricity and magnetism. They really shouldn't never have shoved those two words together. All right, so anyway, till the next time and such and so forth and whatnot.